Now let's continue with some of the vocabulary we'll need for polynomials. Here's our definition of a polynomial. One really important point is to notice that we always take the point of view that a polynomial is a sum. So we always think of subtraction as adding an opposite. For instance, if I had this polynomial, I would need to think of it as 3x squared plus negative 1 times x to the first. That is, both the coefficient and the exponent in this case were implicit, plus a negative 4. So in this example, the constant is a negative 4, because I've taken the point of view that polynomials are sums. We have some special names depending on the number of terms in the polynomial. One-term polynomials are often called monomials. If a polynomial has two terms, we often call it a binomial. And a three-term polynomial is often called trinomial. You don't have to use the words monomial, binomial, or trinomial. For instance, you could also say this is a three-term polynomial. But the words monomial, binomial, and trinomial are much more common. Here I'd like you to write the polynomial as a sum and make all the coefficients and exponents explicit, and then discuss the polynomial in both general and specific terms. See if you can do steps 1 and 2 for this polynomial. First, I'd have to rewrite the polynomial with a coefficient of 1 and an exponent of 1. This is a binomial. The first degree term has a coefficient of 1, and the constant is 14. Try this one. After rewriting the binomial, I can see that my first degree term has a coefficient of negative 1, and again, because I think of a polynomial as a sum, my constant has the value negative 5. With polynomials, there's a degree for each term and a degree for the polynomial in general. To determine the degree of the term, just look at the exponent on the term. For instance, this is a fourth degree term, a third degree term, and a second degree term. The degree of the polynomial in general is the same as the degree of the term with the largest exponent. So in general, this is a fourth degree, 4-term polynomial. Standard form implies that we write polynomials in order of decreasing degree from left to right. For instance, this 4-term polynomial is not in standard form, but I can rearrange the terms so that I have a third degree, and then the second, and then the first, and then the constant, left to right, and now it is in standard form. To write a polynomial in standard form, you should always, again, take the point of view of addition, and then rearrange the terms, and then we rewrite adding opposites back as subtraction. So this whole idea actually has to do with the commutative property of addition, that is, rearranging the terms won't affect the final sum. Most people, though, don't write out all those steps. They simply rearrange the terms in their head. Try to write this polynomial in standard form. The fourth degree term would be first, then the third degree term, the second degree term, and the first degree term, and then the constant. Here's another one. And here's the same polynomial written in standard form. And try this one. After rearranging all of the terms, here would be my polynomial. Notice you don't need to have a term for every single degree. For instance, there is no sixth degree term. So try writing the polynomial in standard form, and then discuss the polynomial in general terms, and last discuss the polynomial term by term. Here's the first one. After rearranging this second degree trinomial into standard form, I can see the second degree term has a coefficient of 2, the first degree term has a coefficient of -1, and the constant is 3. How about here? Again, I would rearrange this third degree binomial into standard form. The third degree term has a coefficient of -15, and the constant is 15. Here's another. First, I'd rearrange the sixth degree 5-term polynomial into standard form. The sixth degree term has a coefficient of -5. The fifth degree term has a coefficient of -6. The second degree term has a coefficient of 6. The first degree term has a coefficient of -4, and the constant is 5. With multivariable or mixed terms, we have more than one kind of variable. In a case like that, the degree of the term is the sum of the individual exponents, but we don't actually add the exponents. For instance, this is a second degree term because we think of this as a to the first and b to the first, and 1 plus 1 is 2. This would be a fifth degree term because the exponent on x would be a 1, and on y we have a 4, and 1 plus 4 is 5. And this would be considered a seventh degree term because the sum of the exponents is 7. Well, that concludes this video where I've gone through some of the vocabulary you'll be using for polynomials.